Hi, welcome back. In the previous lecture, we used replicator dynamics to develop something called Fisher's fundamental theorem. And Fisher's fundamental theorem says the more variation, the faster you can adapt. So that makes sense. It makes sense to then encourage variation because you can adapt more quickly. But notice this runs counter to something we learned early in the class, which was Six Sigma. Now remember the idea behind Six Sigma was, is you've got some landscape here. If you've got a whole bunch of variation, then these ones that are highly variant, like here and here, are going to be low fitness, low payoff, low value. And so you'd like to reduce variation, and if you can get rid of those and only have the ones at the top of the peak, then you're going to do a lot better. So Six Sigma says reduce variation, replicator dynamics says increase it. And Six Sigma works, by the way. There's a wonderful book recently written by Atul Gawande called The Checklist, which showed how in the medical profession, by reducing variation, you did a lot better. So we've got a lot of evidence, right? Here's just one graph on preventing central line infections in intensive care, how when they introduced Six Sigma techniques, what you saw is this massive reduction in the number of infections. So I'm not disputing in any way that Six Sigma works, nor am I disputing in any way that Fisher's fundamental theorem works. It's a fundamental theorem. There's lots of evidence from ecology and biology that in fact that does happen. More variation, more adaptation. So both are true, yet we have this problem in that they're opposite proverbs, right? You're never too old to learn. You can't teach an old dog new tricks. Don't change horses in midstream. Variety is the spice of life. Opposite proverbs. The pen is mightier than the sword. Actions speak louder than words, right? How do we make sense of these things when they contradict? Well, here's where models are useful and proverbs aren't. Our models have assumptions. So what's going on in the case of the Fisher's fundamental theorem, and what's going on in the case of Six Sigma? Well, the way to think of this is to go back to another thing we've learned, the no free lunch theorem. That no theorem, no algorithm, no heuristic, reduce variation, increase variation, is going to work in all settings. You want to understand what settings one's going to work in and what settings the other's going to work in. So let's think about it for a minute. You've got this landscape, and if you've got this landscape, you've got to think, when would you want to use Six Sigma, and when would you want to use Fisher's fundamental theorem? Well, let's suppose this landscape is fixed, and you spent a lot of time and you figured out here's the peak. Well, if you figured out here's the peak, then what you'd like to do is you'd just like to hang out on that peak. You'd like to go Six Sigma. If the landscape stays fixed, then you want to use Six Sigma. But suppose the landscape suddenly moves. Well, if the landscape moves and you're doing Six Sigma, then you have no possibility of moving anywhere. There's nothing to select. There's no new ideas to choose from. So the distinction between when you use Six Sigma and when you use Fisher's fundamental theorem comes down to the nature of the environment. Fisher's fundamental theorem is initially about ecological environments, about dynamic learning environments. So it's basically saying, if the world is churning, if things are changing, then you want more variation. If things are fixed, if they're in equilibrium, then you want to go full Six Sigma. So let's think back. Remember we talked about different types of processes we could have. We could have ordered processes, we could have fixed equilibrium processes, we could have random processes, we could have complex processes. Well, another way to think of that is you can sort of think of equilibrium processes being a process that's stable. It's got a fixed landscape. And you can think of a complex or periodic or a random process as being more like an adaptive landscape, like a dancing landscape. And what you get is in those sorts of worlds, you want more variation. In the equilibrium world, you want to go Six Sigma. So what we learn is, if it's a fixed landscape problem, then what you'd like to do is you'd like to reduce variation and stay on top of that peak. So let's think about Atul Gawande's book, The Checklist. What is he talking about? He's talking about things like getting a plane off the ground. He's talking about things like cleaning tubes that go into people's bodies. We've probably figured out how to do that. Those problems are fixed, and so you want to reduce variation. You want to create a checklist so nobody makes mistakes. What are dancing landscape problems? Well, dancing landscape problems are things in ecology. Species are constantly evolving, ecosystems are constantly changing, and it's innovate, adapt, or die. The same is true in a lot of the business world. If you think of your marketing strategy, that's not a checklist. Because the thing is, your marketing strategy's got to change as consumer preferences change. The landscape is dancing. Or if you're thinking about product innovation, you can't have a checklist. You've got to constantly be changing your product. So some of what you do is straight fixed landscape. It's job shop sort of work. And in those cases, you want to go Six Sigma. Some of what you do is part of a complex adaptive system. Things are constantly changing. In those cases, you want to heed the advice of Fisher's fundamental theorem, which is that the rate at which you can adapt is probably going to be somewhat proportional to the amount of variation you have. So you want to encourage new ideas so you can possibly learn from them. So what we've learned here is by having multiple models, we can then adjudicate which model is going to work in which setting by looking at the assumptions of those models. If we just have opposite proverbs, we're stuck with two contradictory statements. So one of the huge advantages of becoming a many-model thinker is that you can then look at the assumptions of the model. What's the assumptions in Fisher's fundamental theorem is that landscape, that you're not at a peak. And because you're not at a peak, you want to move towards it. In the Six Sigma setting, the presumption is that you're at the peak and therefore you want to reduce variation. So this is, I think, a really nice example, Fisher's fundamental theorem and the contrast with Six Sigma of seeing how thinking with models makes us better able to make sense of the world. All right, thank you.